Welcome, colleagues, to this technical explainer. Let's get right into it. Today we're diving into a framework that rigorously dismantles some of the ad hoc assumptions we've grown so accustomed to in standard particle physics. As lead physicist and department heads, I know we're a skeptical bunch, but I want to show you how mass might actually be derived entirely through the non-linear elasticity principle within an absolute medium. By the end of our time together, you're going to see a perspective where mass is not just some arbitrary label handed out by a theoretical Higgs field, but a strict, calculable, geometric reality.
All right, here's our roadmap for this formal briefing. First, we'll establish the absolute medium framework. Then, deriving mass directly from strain. Third, the mechanics of the strong force. Fourth, volumetric coupling and gravity. Fifth, scaling this all the way from a single proton to a whole planet. And finally, Section 6, redefining black holes as recycling vessels.
So let's jump straight into Section 1, the absolute medium framework. Look, to make this work, we have to entirely abandon the illusions of the standard model. Instead of treating particles as zero-dimensional points and magically assigning them mass, this model relies on the fluid elastic mechanics of a continuous, singularity-free medium. We need to start thinking of matter as a localized topological defect, literally a knot, arising directly from the nonlinear deformation of a continuous substrate. But before we do the math, we need to establish the ground rules. These 8 axioms of persistence and admissibility are a mathematical necessity for maintaining a stable field. They act as an ultimate defense mechanism against dimensional tears. Take the hard irreversible boundary and closure preservation axioms, for instance. They strictly prohibit infinite strain. If the strain approaches causal limits, the system dynamically stalls to prevent a mathematical singularity. In this fluid model, infinite densities simply cannot exist, period.
Moving right along to Section 2, deriving mass from strain.
So, how do we actually run the math on this? Let me walk you through the exact steps for deriving mass from volume integrals of strain. We start by defining the Non-Linear Elasticity Principle, or NLEP, strain energy density. Now, as the deformation of the medium approaches its causal saturation limit, the energy formally diverges toward infinity. But because our axioms completely forbid physical singularities, we're forced to apply a physical regularization, a finite cutoff parameter. By applying a uniform core approximation, we establish a true mass-volume equivalence. Mass is quite literally the geometric receipt for the precise volume of baseline space that was folded up to make the particle.
And this derivation yields something absolutely fascinating, the mass density constant. Based on that microscale cutoff dependency, the effective topological density of any fundamental particle core is a staggering 1.11 times 10 to the 42nd power kilograms per cubic meter. What this tells us is that macroscopic density as we traditionally calculate it is basically just a fluid dynamic illusion dictated by the empty space between atoms. Topologically speaking, the core of an electron and a proton have the exact same density. Their mass difference is driven entirely by the volume of flat space they consume.
Let's move to Section 3, Mechanics of the Strong Force. Now, standard physics constantly suffers from Coulomb singularities when we try to integrate energy down to a zero-radius point. But let's formalize our derivation. By assuming spherical symmetry for the static solution, our equilibrium condition yields an effective stress proportional to an r to the -4 potential. Because these particle cores possess a strict minimum baseline volume, integrating the energy strictly halts at the finite core boundary. This completely averts the classic Coulomb singularity. We don't need to invent any extra gauge bosons. This is just a natural finite boundary condition derived straight from NLP. So, how do these individual cores interact to form atomic nuclei? Standard quantum mechanics leans heavily on overlapping probabilistic wave functions to explain the Pauli exclusion principle. But our continuous fluid mechanics give us a deeply physical, deterministic answer. When two particles are forced together, the absolute medium trapped between them is compressed toward that causal limit we talked about. The NLP strain diverges, causing the medium to undergo what we call shock stiffening. It physically petrifies. This completely reframes the solidity of matter. Two particles can't occupy the same space simply because the medium between them hardens into an impenetrable geometric wall.
Let's break down the field-theoretic calculation of this hadronic energy interaction bridge. We decompose the interaction volume and integrate the NLEP energy functional. When we apply a leading-order uniform bridge approximation to find the effective force transmitted, we calculate the thermodynamic work required to saturate this medium. And the result? Exactly around 60 mega-electron volts. The math effortlessly produces the observed hadronic excitation scale.
In this view, mesons aren't independent particles pinging back and forth, they are literally just the energetic cost of stiffening the medium between nucleons. On to Section 4, volumetric coupling and gravity. The volumetric coupling principle is absolutely crucial because it explains the transition from microscopic femtometer physics to macroscopic celestial mechanics. Because particles aren't mathematical points, they possess an inflated active skin spinning to protect the core. Ambient kinetic waves and macroscopic advective flows physically couple directly with the surface area of this fluid dynamic skin. This dictates that matter cannot interact as a zero-dimensional point, which effectively eliminates point source gravity and all the singularities that plague general relativity. This framework elegantly handles force unification. When we contrast the absolute medium's fluid mechanics against the standard quantum chromodynamics view of discrete gauge bosons, the scale-dependent interaction principle emerges. QCD and general relativity are really just two different regional behaviors of the exact same fluid elastic medium. Up close to the core, extreme strain causes NLEP shock stiffening. That's our strong force. Further away, the strain relaxes into smooth advective flow. That's gravity. It's one medium acting across two scales. Section 5. Scaling from proton to planet. Let's anchor all these derivations with some concrete numbers. Calculating the true topological volume, we find that tying the knot of a single proton requires forcefully gathering exactly 1.50 times 10 to the negative 69th cubic meters of the flat baseline universe and permanently locking it into a frozen vortex.
But watch what happens when we scale this up to macroscopic aggregates. If we calculate only the actual space permanently folded to make up the entire baryonic mass of the Earth, its absolute baseline equivalence is a mere 5.37 times 10 to the negative 18th cubic meters. That is literally smaller than a single grain of sand. It proves that our everyday reality is overwhelmingly constructed of unfolded, unstrained space just sitting between atoms.
Finally, Section 6. Black holes as recycling vessels. As you well know, standard physics treats black holes as infinite mathematical singularities. But our framework mathematically prohibits this. As extreme advective pressure crushes particles, their active skins compress down to the critical degenerate volume, which is what we observe as the neutron star limit. If pressure continues, these cores seamlessly merge, forming a macroscopic isolation bubble. But this isn't a static, dead void. It's a highly stressed tension vessel trapping immense kinetic energy. When the internal kinetic pressure eventually overwhelms the structural boundary of the vessel, it triggers a cosmological burst mechanism. Far from being infinite singularities causing the heat death of the universe, black holes serve as temporary recycling vessels for folded baseline canvas that eventually burst, completing an eternal cosmological engine.
I'll leave you, my colleagues, with this final, provocative thought. If the math dictates that the solid mass of an entire planet is constructed from a literal speck of folded space, what does that reveal about the immense, hidden kinetic power of the empty void you are sitting in right now? If the vacuum is truly an absolute medium under extreme pressure, we must entirely rewrite our relationship with the space that connects us. Thank you for your time on this explainer.